Hi, and welcome to Calculus 30 with Miss Verity. Today we're looking at 3.3b, which is just more ways to evaluate limits. When looking at limits, the first thing you always want to try is direct substitution. So if I was to plug 5 in here, and I was to simplify, we'd get 5. Nope, that's not what we get. We would get 0 over 0. When you have 0 over 0, obviously you can't use direct substitution. That is a whole, which means we have a common factor in our function. Well, first of all, we don't like stacked fractions, so let's rewrite this. So 3 over 2 minus 3 over x minus 3. We are going to multiply that by 1 over x minus 5. So remember, dividing by x minus 5, we're going to multiply by the reciprocal in terms of fractions. So simplifying what we have, we have 3 over 2 x minus 5 minus 3 over x minus 3, x minus 5. Okay, in order to add our fractions, we need a common denominator, which means this first term needs a x minus 3. So x minus 3, x minus 3. So now what our functions have are 3x minus 3 over x minus 3, x minus 5, and we have the 2. I'm just going to throw that out front. Minus, this other side needs a 2, so 6 over 2x minus 3, x minus 5. Now that we've got common denominators, we can just do the math and everything can be under one denominator. So 2 steps at once, we're going to distribute 3x minus 9, and we're going to combine it all under one fraction. So 2x minus 3, x minus 5. Now that we've got everything as a fraction, simplify. So 3x minus 15 all over 2x minus 3, x minus 5. Taking out a common factor of 3, we're left with x. X minus 5 all over 2x minus 3, x minus 5. Well, huzzah, our goal was to find a common factor, and we did. So those cancel out. We are left with 3 over 2 x minus 3. And now that we've gotten rid of our common factor, now we can do our direct substitution. So the limit as x approaches 5, because remember, this common factor right here, if we plugged 5 into there, that's why we're getting 0. So 3 over 2 times 5 minus 3, 3 over 2 times 2, which is 4. All right, our next strategy for evaluating limits is by rationalizing. If you recall from pre-calc 20, rationalizing is where you've got a radical and you need to multiply by its conjugate. So the conjugate is the thing with your radical with the opposite sign. So again, we check our direct substitution, we're going to get 0 over 0. Direct substitution is always your go-to. It's the easiest thing. So you're going to multiply by the root of x plus 10 to both our numerator and our denominator. Because this is our conjugate, the conjugate has the opposite sign, but the numbers stay the same. So the conjugate, if you remember, gives you a perfect square minus a perfect square. So we're squaring the first term. So root of x squared is x minus, it's going to be 100 over, when you're multiplying by the conjugate, don't multiply your denominator. There we go. So now we have basically forced a common factor. We are going to then, now that our common factor is gone, find the limit as x approaches 100 in our function 1 over the root of x plus 10. So that's going to be 1 over the square root of 100 plus 10, so 1 over 10 plus 10, which is 1 over 20. So next example, same thing, we're going to multiply by our conjugate, because if we did direct substitution, we're going to get 0 over 0. So we're going to multiply by the root of 10 minus x plus the root of x minus 2. It's just the sign in between your two terms that's changing. 10 minus x plus the root of x minus 2. So in our numerator, 6 minus x, we're going to leave the root of 10 minus x plus the root of x minus 2 all over. So now it's going to be the first term squared, so that's going to be 10 minus x minus the last term squared. Don't forget to leave your brackets in there because we need to distribute that negative. So 6 minus x, root of 10 minus x plus the root of x minus 2 all over, so 10 plus 2 is 12, negative x plus, something happened. What happened? Oh no. Oh, negative x minus x, silly me. That is negative 2x. Okay, so again, we're just going to leave our numerator. 6 minus x, the root of 10 minus x, plus the root of x minus 2 all over. We're going to take out our common factor of 2. We're left with 6 minus x. Lo and behold, we have a common factor. So now our function that we're left with is the root of 10 minus x plus the root of x minus 2 all over 2. Now that our common factor is gone, we're going to take the limit as x approaches 6. And we have the square root of 10 minus 6 plus the square root of 6 minus 2 all over 2. So square root of 4 is 2 plus the square root of 4 is 2 all over 2. 4 divided by 2 is 2.